Welcome to another Deep Dives today, and, well, we're going to try to cover a lot of ground.
Yeah.
We're going to talk about the entire history of planet Earth,
Oh, wow.
from its formation billions of years ago to the emergence of humanity.
Okay.
So, pretty ambitious goal for today's Deep Dive.
Yeah, it's a mind-bogglingly huge amount of time that we're going to try to cover.
Yeah, we're talking about, billions of years.
Right, and it's hard for us as humans to really wrap our minds around those kinds of timescales.
Yeah, I mean, like, if you think about it, 1,000 years is already a really long time.
Right.
But we're talking about thousands of years.
Exactly.
So let's try to break this down and start at the very beginning.
Okay.
What was Earth like in its very earliest days?
Yeah, you have to imagine this swirling cloud of dust and gas.
Oh, wow.
This is the remnants of exploded stars.
Okay.
And that's where our story begins about 4.54 billion years ago.
All right, so we're going way back.
Way back.
And this cloud of dust and gas has a name, right?
It's called the Solar Nebula, and it starts to collapse in on itself due to gravity.
So it's like a giant cosmic dust bunny just kind of coming together.
Exactly. You can think of it that way as all this dust and gas comes together, they start to collide, and that generates a tremendous amount of heat.
So this is where all the heat comes from.
Yeah, over millions of years, this process called accretion is what forms our planet.
Okay, so Earth is literally born from a cloud of stardust.
That's right. It's a pretty poetic origin story.
But I'm guessing it wasn't exactly a peaceful birth.
Oh, no, not at all. This early Earth was a molten inferno.
Oh, gosh.
You have volcanoes erupting, constantly spewing lava and gases, and it's a scene of unimaginable chaos and heat.
It's interesting to think about how something that's so familiar to us now, like our planet,
Right.
had such a, violent and chaotic beginning.
Yeah, it's a completely different world than the one we know today.
So not exactly a place you'd want to visit.
No, not unless you're really into extreme heat and molten rock.
All right, well, let's move on to something a little bit more familiar, and that is the moon.
Okay.
So how did the moon enter the picture?
The moon. Well, that's a story that really captures the imagination.
I'm ready.
Early Earth was struck by a Mars-sized object,
Whoa.
and that object had a name. We call it Theia.
Okay.
And the energy released in that impact is just mind-boggling.
I can only imagine.
Debris was blasted into orbit.
Okay.
And over time, that debris coalesced to form our moon.
So the moon is basically a piece of Earth that got knocked off in this giant cosmic collision.
Yeah, that's a simplified way of putting it, but essentially, yes. And you know what's even more incredible?
What?
That impact that created the moon actually played a crucial role in shaping Earth's destiny.
Okay, I'm intrigued.
So for one thing, the moon's gravitational pull is what creates the tides that we experience today.
Oh, that's right.
But it also helps to stabilize Earth's rotation, which prevents wild wobbles in our planet's axis, and that stability is crucial for maintaining a stable climate, which in turn is essential for the evolution of life.
Wow, so the moon is way more than just a pretty face in the night sky.
Exactly. It's a fundamental part of what makes Earth habitable.
I never really thought about it that way. That's fascinating.
But let's get back to our story. After the chaos of its formation, Earth gradually starts to cool down.
Okay.
This takes millions of years.
All right, so we have this molten lava starting to solidify.
Right.
What happens next?
As the planet cools, a solid crust forms,
Okay.
and something really amazing happens. Liquid water appears on the surface.
Liquid water, the essential ingredient for life.
Exactly, and deep beneath that water, the first continents begin to emerge from the churning mantle.
So these are like protocontinents.
You can think of them that way. We call them cratons.
Cratons.
Yeah, they might sound strange, but they're actually the ancient hearts of our modern continents.
So the continents we know today are built on these ancient cratons.
Yeah. That's right. They've been growing and changing over billions of years.
That's amazing.
Yeah.
It's hard to even imagine what those early continents must have looked like.
Yeah, very different from the world we know today.
So we've got Earth cooling down, we've got water, we've got continents starting to form.
Right.
When does life enter the picture?
Well, in those early oceans, something truly remarkable happens. Life emerges.
Life emerges.
Simple, single-celled organisms, the ancestors of every living thing on Earth.
It's mind-boggling to think that something so small could be so significant.
It is. And you know what's even more fascinating is that these early life forms weren't just passive passengers. They actually started to change the planet itself.
Okay, how so?
Well, some of them, called cyanobacteria,
Cyanobacteria.
evolved the ability to photosynthesize.
Photosynthesis, using sunlight to create energy and releasing oxygen as a byproduct.
Exactly.
I remember learning about that in school.
It was a game changer for sure.
Yeah.
Oxygen, which was initially toxic to many life forms, gradually transforms Earth's atmosphere.
So it's like these tiny organisms were terraforming the planet.
Exactly. They were paving the way for the evolution of more complex life.
So we owe our very breath to these ancient bacteria.
That's right. It's pretty humbling.
It is, but I've also heard that early Earth wasn't always a very welcoming place.
Yeah.
What about these snowball Earth events that I've read about?
Oh, yes. The snowball Earth events, these were periods of extreme glaciation where much of the planet, even the tropics, was covered in ice.
The entire planet covered in ice.
Pretty much imagine a world where the oceans are frozen over and glaciers stretch across entire continents.
That's hard to even fathom.
Yeah, it's a completely different world than the one we know today, and it's hard to imagine how life could have survived in such conditions.
It sounds incredibly harsh.
Yeah.
So how did life manage to persist?
Well, life is incredibly resilient.
That's for sure.
Even in those frozen wastelands, there were pockets of warmth and liquid water. Perhaps around volcanic vents or in areas where the ice was thinner. And in those pockets, life found a way to cling on, evolving and adapting to the extreme conditions.
So even in a snowball, Earth life finds a way.
Exactly. It's a testament to the tenacity of life.
It is. So we've gone from these single-celled organisms to this incredibly harsh environment.
Right.
But somehow life manages to survive.
Right.
So how did we get from those single-celled organisms to the incredible diversity of life that we see today? I mean, that's a huge leap.
It is a huge leap, and it involved a series of key innovations. One of the most important was the evolution of eukaryotic cells.
Eukaryotic cells, refresh my memory on those.
So these are cells with a nucleus
Okay.
and other complex structures like mitochondria, the powerhouses of the cell.
Right.
There's the building blocks of all plants, animals, and fungi.
Okay.
And the way they evolved is fascinating.
Okay, tell me more.
It involved a process called endosymbiosis.
Endosymbiosis, break that down for me.
Essentially, one cell engulfed another, and instead of digesting it, they formed a mutually beneficial relationship.
Oh.
This is likely how mitochondria, which were once free-living bacteria, became an integral part of eukaryotic cells.
So it's like a cell eating another cell, but instead of destroying it, they team up.
Exactly. It's
Yeah.
a beautiful example of cooperation and interdependence driving evolution.
Teamwork makes the dream work even at the cellular level.
Exactly. And that teamwork set the stage for even greater complexity and diversity in the history of life.
Okay, so we've got eukaryotic cells, we've got multicellular organisms. Things are starting to get interesting.
Right.
What happens next in this epic saga of life?
Well, remember those cratons we talked about earlier?
The protocontinents.
Exactly. They continued to shift and collide, forming larger landmasses. Imagine a vast supercontinent called Rodinia straddling the equator.
Rodinia, that's a cool name.
But this supercontinent didn't last forever.
Uh-oh.
It eventually broke apart, triggering dramatic changes in climate and ocean currents.
So these giant land masses were constantly on the move, shaping the planet and influencing the evolution of life.
Exactly. And then about 538.8 million years ago, something truly remarkable happens. It's called the Cambrian explosion.
The Cambrian explosion, that sounds dramatic. Tell me more.
It was a period of rapid diversification of life. Imagine the oceans suddenly teeming with a dazzling array of new and bizarre creatures.
Okay, I'm picturing it.
Trilobites scuttle across the seafloor. Strange creatures like Anomalocaris with their spiky appendages hunt their prey. And the first vertebrates, the ancestors of all fish, make their appearance.
Wow, so many new creatures all of a sudden.
It was an explosion of life, and it's one of the most significant events in the history of life.
So the Cambrian explosion really set the stage for the diversity of life that we see today.
It did, and you know what's even more amazing?
What?
Life wasn't content to stay confined to the oceans.
You mean life started to move onto land?
Exactly. Plants and fungi were the first pioneers venturing onto a barren and hostile
They're
landscape.
brave little pioneers.
They were followed by arthropods, the ancestors of insects and spiders adapting to this completely new environment.
It's incredible to picture those early pioneers transforming a lifeless landscape into a vibrant terrestrial ecosystem.
It was a slow and gradual process, a testament to the power of adaptation and evolution. And then something even more remarkable happened. Fish, those masters of the underwater world, began to evolve the ability to walk on land.
Wait, fish walking on land, that sounds like a recipe for disaster.
Well, it wasn't an overnight transformation.
Okay.
We have fossils like Tiktaalik,
Tiktaalik.
a fishapod with limb-like fins that show us the transitional forms that bridge the gap between water and land.
So Tiktaalik was like the first tentative step toward land-dwelling vertebrates.
Exactly, and this paved the way for even more dramatic evolutionary changes.
I'm hooked. What happens next?
Well, this was the beginning of the tetrapods.
Tetrapods.
Four-limbed creatures that would eventually give rise to amphibians, reptiles, birds, and mammals, including eventually us.
Okay, so we've got life conquering the land, evolving and diversifying. This is where things really start to take off, right?
You got it. And you know what comes next?
I think I know, but tell me.
The age of dinosaurs.
The dinosaurs, everyone loves
The
dinosaurs.
fascinating creatures, and they dominated the planet for millions of years.
They were the rulers of the earth for a very long time.
They were incredibly successful, evolving into a mind-boggling array of forms and sizes.
Yeah, from giant long-necked sauropods to fearsome predators like Tyrannosaurus rex.
Exactly, and they had a significant impact on the environment. Large herbivores shaped vegetation patterns with their grazing, and predators played a key role in regulating prey populations.
It must have been an incredible sight to behold.
Oh, absolutely, but their reign didn't last forever.
Right, the dinosaur-killing asteroid.
It's one of the most famous events in Earth's history.
Yeah, it's kind of sad to think about the end of the dinosaurs, but I guess it also created opportunities for other life forms to evolve.
That's right. As devastating as extinctions are, they also create opportunities. They reset the evolutionary clock, so to speak, opening up niches for new species to emerge and diversify.
So with the dinosaurs out of the picture, who were the next superstars to take center stage?
Well, with the dinosaurs gone, mammals, which have been living in their shadow for millions of years, had their chance to shine.
The underdogs rise up.
Exactly. They diversified and thrived, evolving into a wide range of forms, from tiny shrews to giant whales, and among those mammals were the primates, our own lineage.
Okay, so that brings us closer to home. How did those early primates eventually lead to us Homo sapiens?
It's a fascinating story, and one that we'll delve into in more detail in the next part of our deep dive, but let me just give you a sneak peek.
Okay, I'm ready.
About 6 million years ago, a small African ape lived.
Okay.
And its descendants would eventually include both modern humans and our closest living relatives, the chimpanzees.
So we share a common ancestor with chimps. That's always mind-blowing to think about.
It is, and from that common ancestor, the human lineage embarked on a remarkable evolutionary journey.
So we stood up straight, our brains got bigger, and we started using tools.
Exactly. We developed bipedalism, walking upright on two legs. Our brains grew larger, and we developed increasingly complex tools and social structures.
From those early hominids to the humans we are today, that's a journey I'm eager to explore.
It's an incredible story.
But for now, I think we've covered a lot of ground. We've traced the history of Earth, from its fiery birth to the rise of mammals and the emergence of our own lineage.
It's been quite a journey, hasn't it?
It has, and it's just the beginning. In the next part of our deep dive, we'll explore the fascinating story of human evolution and the rise of civilization.
I can't wait to get into that.
This is where things get really interesting. So we'll be back in a moment to continue our epic exploration of Earth's history.
Welcome back to our deep dive into the history of Earth. So, as we were saying before the break,
Right.
that small African ape about 6 million years ago really set the stage for the emergence of humans.
Yeah, and I'm really curious to learn more about that journey. So what were some of the key developments that set our ancestors on the path to becoming human?
Well, one of the most significant changes was bipedalism,
Bipedalism.
walking upright on two legs.
Okay.
It freed up our hands to use tools and carry things, and it also gave us a different perspective on the world, literally.
So standing up straight wasn't just about posture. It actually played a role in our evolution.
Exactly, and as our ancestors ventured out onto the savannas of Africa, they faced new challenges and opportunities. The ability to walk long distances efficiently would have been a huge advantage.
Right. It would have allowed them to forage for food over wider areas.
Exactly, and that would have given them a competitive edge.
That makes sense. But what about our brains? They're kind of a big deal.
Oh, absolutely.
Right.
Over time, our ancestors' brains grew larger and more complex. This allowed for greater intelligence, problem-solving abilities, and social interactions.
So we're getting smarter.
Yeah, and don't forget about tools. Early humans started using simple tools millions of years ago, and those tools became increasingly sophisticated over time.
So we're walking upright. We've got bigger brains. We're using tools. What other milestones marked our journey to becoming human?
Well, the controlled fire was a game changer.
Fadi.
Imagine the impact of having a source of warmth, light, and protection at night.
Right.
It also allowed us to cook food, making it easier to digest and unlocking more nutrients.
Yeah, I definitely wouldn't want to go back to eating raw meat all the time. But what about language? When do we start talking to each other?
That's a tricky one. The origins of language are difficult to pinpoint.
Okay.
But as our brains evolved and our social structures became more complex, communication must have played a vital role.
I can imagine.
And as language developed, it likely fueled further cultural and technological innovation.
It's amazing to think about how something as simple as sharing ideas through language could have had such a profound impact on our evolution.
It's truly remarkable. And speaking of remarkable, for most of human history, we lived as hunter-gatherers, relying on our skills and knowledge of the natural world to survive.
Right, nomadic tribes moving from place to place in search of food and resources.
Exactly. But then something happened that would change the course of human history.
Okay, what was that?
Around 10,000 years ago, in a region known as the Fertile Crescent, humans began to systematically cultivate plants and animals.
The dawn of agriculture.
Exactly.
That's a huge shift in human history. What led to that change?
Well, it was likely a combination of factors, including changes in climate population growth and a deeper understanding of plant and animal life cycles.
Makes sense.
And the impact of agriculture was profound.
In what way?
Well, it allowed for the production of surplus food, leading to settled communities, larger populations, and the development of more complex social structures.
So instead of chasing after our food, we started growing it ourselves.
Exactly, and that freed up a lot of time and energy for other pursuits.
That must have had a ripple effect across all aspects of human life.
It did, and that's what led to the rise of civilizations.
Civilization.
With more time and resources at their disposal, humans began to develop specialized skills and knowledge.
Okay.
We see the emergence of artisans, priests, warriors, and ruler cities began to grow, trade networks expanded, and new technologies were invented.
So from those early farming villages in the Fertile Crescent, we see the seeds of civilization being sown.
Exactly. It's a fascinating transition.
It is. What were some of the key innovations that emerged during this time?
Well, the invention of writing was a major milestone.
Right.
It allowed for the recording of information, the sharing of knowledge across generations, and the development of more complex forms of government and administration.
So writing was a game changer.
It was a huge leap forward for human civilization.
Okay, so we've got writing agriculture cities. It's like a domino effect of innovation and change.
Exactly. One innovation led to another, and human societies became increasingly complex.
And I'm guessing this is where we start to see the emergence of empires and large-scale political entities.
You're right. As civilizations grew and interacted with each other, they sometimes clashed, leading to the rise of powerful empires that spanned vast territories.
Like a Roman Empire.
Exactly. The Roman Empire is a classic example with its impressive infrastructure, its military might, and its influence on culture and law.
Empires definitely not known for their small-scale operations, but these empires also left a significant mark on the environment, right?
That's an important point. As human societies grew and became more complex, their impact on the environment intensified.
How so?
While deforestation, mining, and the diversion of water resources became increasingly common.
So it's a bit of a double-edged sword. We're seeing incredible human ingenuity, but it's starting to have unintended consequences for the natural world.
Exactly, and those consequences would become even more apparent as we moved into the Industrial Revolution.
The Industrial Revolution, that's a turning point in human history, and not just in terms of technology. What were some of the key environmental impacts of that era?
Well, with the invention of new machines and the harnessing of fossil fuels, we see a dramatic increase in manufacturing, transportation, and energy consumption.
Okay.
And that had a huge impact on the environment.
In what way?
Well, the burning of coal and oil releases greenhouse gases into the atmosphere, contributing to climate change.
Right.
And factories pollute air and water, leading to health problems and environmental degradation.
So while the Industrial Revolution brought about incredible progress, it also unleashed a whole new level of environmental challenges.
It was a complex legacy, and the challenge we face now is how to learn from the past and create a more sustainable future.
Okay, so we've covered a lot of ground here. We've traced the evolution of humans, the rise of civilization, and the growing impact of human activities on the planet. But this is just part of the story, right?
It is. In the next part of our deep dive, we'll explore what happened as we entered the 20th and 21st centuries, and we'll delve into the complex environmental challenges we face today.
I'm ready to dive in. We'll be back in a moment to continue our exploration of Earth's history and the incredible story of humanity's relationship with the planet. Welcome back to our deep dive into the history of Earth. So we've journeyed from the planet's fiery birth to the rise of civilizations and the Industrial Revolution.
Yeah, and we've seen how Human ingenuity and innovation have shaped the world in profound ways.
For sure. But they've also brought about some serious environmental challenges.
Yeah.
As we moved into the 20th and 21st centuries, those challenges became even more pressing.
Definitely.
Climate change, biodiversity loss, pollution, resource depletion.
Yeah.
Issues that are all interconnected and affect every corner of the planet.
It's a complex and daunting situation.
It is.
But I think it's important to remember that we're not just passive observers in this story.
Right.
We have the capacity to understand these challenges
Yeah.
and to find solutions.
Okay, so let's talk solutions.
Mm-hmm.
What are some of the ways humans are working to address these environmental issues and create a more sustainable future?
Well, first and foremost, there's a growing awareness of the problems.
Okay.
More and more people are recognizing the urgency of the situation, and that's crucial.
Yeah, you can't solve a problem you don't acknowledge.
Exactly. Awareness is key.
But how do we translate that awareness into action?
Well, that's where things get exciting. We're seeing innovation and problem solving across a wide range of fields.
Like what?
Well, in renewable energy, for instance.
Okay.
We're seeing rapid advancements in solar, wind, and geothermal technologies.
That's good to hear. Shifting away from fossil fuels is essential if we're going to tackle climate change.
Absolutely. And it's not just about replacing dirty energy sources with clean ones.
Right.
It's also about reducing our energy consumption through efficiency measures and lifestyle changes.
So like using less energy at home, driving less,
Exactly.
making more conscious consumer choices.
All of those things can make a difference.
What about other areas where we're seeing progress?
Well, in agriculture, there's a growing movement towards sustainable practices. Things like regenerative farming, permaculture, and organic agriculture.
These approaches focus on building soil health, reducing chemical inputs, and enhancing biodiversity, right?
That's right. It's about working with nature rather than against it.
To produce the food we need.
Exactly. And there are exciting developments in conservation, too.
Oh, yeah, like what?
Well, scientists and conservationists are working to protect endangered species, restore ecosystems, and create more resilient landscapes.
So it's not just about undoing the damage we've done.
Right.
It's also about creating a more harmonious relationship with the natural world.
I agree, and technology is playing a role, too.
How so?
Well, for example, carbon capture and storage technologies are being developed to remove carbon dioxide from the atmosphere.
Oh, wow.
And we're seeing innovations in materials science with the development of bioplastics and other sustainable alternatives to traditional plastics.
It sounds like there's a lot of work being done on multiple fronts.
There is.
But ultimately, it's not just about technology, is it?
No, it's not.
It's about changing our behavior, our
Mhm.
consumption patterns,
Sure.
our values.
You're absolutely right. We need systemic change, and that starts with individual choices.
Right.
But it also requires government policies, corporate responsibility, and collective action on a global scale.
It's a tall order, but I think we've learned something important from our deep dive into Earth's history.
What's that?
Life is incredibly resilient.
That's for sure.
It's faced countless challenges, from asteroid impacts to ice ages.
Yeah.
And yet it's always found a way to adapt and evolve.
And if life can do it, so can we.
Exactly. You have a responsibility to this planet, to all the life it supports, and to future generations, and we have the capacity to make a difference.
Well said.
So as we wrap up this epic journey through time, what's the one key takeaway you want our listeners to remember?
I think it's this. We've explored the vastness of geological time, the incredible story of life's evolution, and the profound impact of humanity on the planet. And now, armed with that knowledge, we have the opportunity and the responsibility to shape a more sustainable future.
Couldn't have said it better myself. It's been an incredible journey.
It has.
Thanks for joining us on this deep dive to the history of Earth.
My pleasure.
And remember, the story isn't over yet. We're all part of it. And the choices you make today will determine what the next chapter will look like. Thanks for listening.